Hey everyone, it's Jason from Code Monkeys, and in this video, we're going to be looking at another LeetCode problem, and it's going to be the climbing stairs problem. So in this problem, we are going to be climbing a staircase, and it takes n steps to reach the top of the staircase, okay? So each time we can either climb one or two steps, all right? So we can do either just one step up or two steps up. And in how many distinct ways can we climb to the top? All right, so they give us some examples down here. They give us an example when the input is n is equal to 2, and then our output is 2. So there's two ways that we can climb to the top, and they give us an explanation. And the one way we can do it is we could take one step, and then we could take another step, or we could just take two steps. And then they give us another example here where the input is n is equal to 3. And the output is 3, so there's 3 unique ways that we can climb to the top of the staircase. And they give us, this one step plus one step plus one step. We could take one step and then we could take two steps, or we could take two steps and then take one step. Okay, and then they give us some constraints for the problem, which is that n is going to be greater than or equal to 1 and less than or equal to 45. All right, so before I get into my thought process, if you want to go ahead, give the problem a try yourself, and then you can come back, and then we can talk about my thought process. All right, so I'll give you a second to pause the video. Okay, guys, welcome back. Hope you're able to give that problem a try. Now we can go through my thought process. All right, so, we can take these simple examples. So we have our simple examples that they gave us, right? And let's see if we can find some pattern. All right, so when we have, our example, so let's think about when n is equal to 1. So we know that in that case, there's just one way. There's one way to climb to the top, which is just taking one step, right? So that's like a simple, trivial one. And then they gave us when n is equal to 2, like we see over there. So when n was equal to 2, we had our two ways to climb to the top. And then we can look at when n is equal to 3, and like the example they gave us over here, we're gonna have 3 ways to climb to the top. All right, so these are some simple examples that we can start with to maybe see if we can come up with a pattern. So I think something that's helpful when we're kind of doing a problem like this is to maybe draw out some diagram. And I already drew out a diagram over there. So let me just copy and paste it in. So here's a little diagram that could be helpful in doing this. So this is our starting point, basically. So we're starting at the bottom of the staircase. And then over here, you can like add in 1 over here, right? So basically, if we take one step, then we're going to, end up over here. And this will be the case, should also say this, that this is the case when n is equal to 3. So we're going to look at a diagram for when n is equal to 3 to see if looking at the diagram can help us come up with some type of a pattern. So start at the bottom of the staircase. And if we take one step, well, now we're 1 out of 3 steps to the way to the top. Okay. And over here, if we take 2 steps, then we're 2 out of 3 up to the top. And then down here, we could take another 1 step, and now we're 2 out of 3 steps that we need to take to the top. And then over here, okay, if we took 1 step and then 2 steps, now we're 3 out of 3. All right, so we're at the top. So this is one sort of, pattern of steps that we could take to get to the top, right? And over here, if we just took 1 step, over here, just backspace this a little bit, then we're also going to be at the top. So, we take that 2 step and then that 1 step. And then if we continue with this diagram, and if we come over here, then if we took another 2 steps, so if that was a path that we took, then we'd have 4 out of the 3. So now we've taken an extra step. So we don't even need to really worry about that. So we can kind of just cross that out. Okay. And then down here, if we continue with our diagram, then from here we could take another 1 step. And then we come down here and now we have 3 out of 3 steps. And if we come over here and we take 2 steps, well, then we end up in the scenario that we had over here, which is basically we took an extra step, right? So we did 1 step, and then 2 steps. So then we took an extra step, so we can ignore that case. All right. Now, something else that may be helpful here, and again, if you have any ideas or thoughts when I'm going through my thought process, then pause the video and try out a solution yourself. But another thing that could be helpful is drawing a diagram for larger values of n, or just a general diagram of n. So basically, if we did it for, n is equal to 4, n is equal to 5, or if we did it just for a general, diagram with a value of n, then we might be able to start to see some type of a pattern arise with our different, numbers of steps that we can take. Now, if you've ever used recursion before, then you may have noticed that this diagram that I drew up here, that's actually a recursive tree diagram. All right, so this diagram and this sort of way of thinking about this problem should, immediately tell us like, all right, we could use, recursion to solve this problem. So now what we need to do is we need to come up with some sort of recursive formula to solve this problem. All right, so if you think you could come up with one, based off of this diagram and what you know about recursion, then pause the video and give it a shot. All right, so when we're looking at our diagram up here, we see that we can either take 1 step or we can take 2 steps to reach our target of n steps to get to the top, right? So one way that we can kind of think about this is, all right, what are the, how many steps have we taken? So we could say like steps taken, right? That can be some variable that we'd care about, because we want to know how many steps we've taken so far to reach the top. All right, now we know that we can take 1 step or 2 steps. So whatever our steps taken is going to be, so it could be, it could be +1, right? So this could be like initially our steps taken is 0, right? And then our steps taken could either be +1, or we could do whatever our steps taken is +2. And what we're trying to figure out here is ways that we can climb to the top. So, we could come up with a function. We could say like, way to climb. And that function, we can give it how many steps we've taken. So steps taken. And we know that we can take 1 step to get there. And something else that we care about is we care about our target number, right? So when do we know that we've reached the top of the staircase, basically? So in our function, we could also pass the value of n, which is our target. That's how many steps that we'd want to take. So this is sort of one way to climb to the top. And another way that we could climb to the top would be that if we use this way to climb function, and we could pass it steps taken, and we could add 2 to it, right? So this is like if we were to take 2 steps, right? So instead of 1. So this function, when we call this function over here and we pass in steps taken +1, this is going to, handle this case, right? When we're taking 1 step along the tree. But we also have a scenario where we could take 2 steps. Like over here, if we just take 2 steps from the beginning, right off the bat there, or if we just took 2 steps there, after we took 1 step. So this is kind of a way to summarize this recursion tree up here. Now, if you've seen recursion before, this formula would, you'd probably be used to it and make some sense to you. If you've never seen recursion before, then, maybe look it up, learn about it a little bit, and maybe I'll make a video about it or something in the future too. And all right, so now we have our sort of formula here, but there are some things that we need to pay attention to, which are, how many times are we going to need to call this, right? So how many times should we call these functions to reach the top? All right, so that's a question we need to answer. So one thing that we know is that we know that if the steps taken, if that's greater than n, so if the steps taken is greater than n, right, that can happen from our recursion tree. We've seen that if we add 1 and then 1 and then 2, well, we'll end up in a scenario where steps taken is greater than n. So if that happens, then we can ignore this case. All right, and another scenario would be that if we reach the top, if we have a valid pattern of steps to reach the top, so if steps taken, if that's equivalent to n, then we found a valid pattern. All right, so using what I've written out here in this formula that I've given you, you might be able to now come up with a solution. All right, now let's get into an implementation. All right, so here is our implementation. And I'll just copy over this over here. Paste that in there. All right, so what we need to do is in this climb stairs function that they gave us over here, we need to return a way to climb, right? So our way to climb function that we talked about. Now, initially, like we said, our steps taken is going to be 0. So we can just pass in 0 to that. And then we also care about n. We also care about how many steps we need to take to get to the top, all right? So that's what we can put into that function. Now, another thing that we can do is we can create our way to climb function, right? So we need to create this, so we can call it in there. So this will be our way to climb. And in this function, we need to pass in steps taken and our value of n. And let me write this out properly. Pass in function to that. Okay. Now, all right, there we go. So this is going to be our way to climb function. So we want to take in steps taken. So how many steps have we taken? And then we want to take an n. Now we have two different cases, right? So our one case is if the steps taken, if that's greater than n, so if that's greater than our target value, then we don't care about it, right? So we can ignore it. Like we saw up here in the diagram. If we end up in a scenario where we end up with 4 out of 3 steps, then we can ignore it, right? In the case when n would be equal to 3. So in that case, we can just return 0. Now, another thing that could happen is if steps taken is equivalent to n, right? So now we've found a valid pattern, right? We found a pattern where we've taken, 3 steps in the case when n is equal to 3 to get to the top. So that would be a valid pattern. And if that's the case, then we found one of the valid patterns, so we can just return 1. All right? Let me just put some semicolons in here. All right. Now, we also have our recursion formula that we came up here, our recursive formula. So I can just copy that. Let me just copy that in down here. And we want to return this. All right. Now, what we're doing here is we're calling way to climb function, right? So we're using this recursive pattern that we noticed when we drew out our diagram, right? So we have way to climb, and we want to pass in steps taken, and we have the option every single time we're taking a step to take one step, and we can also take 2 steps, right? So this will kind of just go through and go through the case when we take 1 step and then 1 step and then 1 step. It'll go through like 1 step and then 2 steps, and it'll go through and do 1 step and 1 step and 2 steps, and then if we did 2 steps first, and so on and so on and so on. So that's what this formula is doing. Now, this formula, this algorithm that we wrote over here should work. It should just, be fine. Now, so what we can do is, let me just save this, and then I'll copy this and put this over here. All right, so then if we come down here and we submit it, you may be able to notice it right here, what's potentially going to happen here. And it might take a second to actually finish judging it. But basically, we're going to end up with a time limit exceeded. So what that means is that our algorithm that we wrote, it isn't necessarily wrong, but the time complexity isn't that great, right? So the solution is taking a long time for larger values of n. All right, now, if you know why this is happening, then, that's great. And I'm going to take some time to kind of explain why this is happening. And then in the next video, we'll come up with an even better solution to solve it. All right, guys, so our solution, it works, but we did get the time limit exceeded. Now, this is happening because the time complexity of our solution, that's going to be big O of 2 to the n. All right, so this is the time complexity of our solution that we came up with here. So this isn't a very efficient solution. Now, one of the ways that we can sort of come up with this as the time complexity of it is this is the number of times that our algorithm over here is going to run. Now, one thing that we can do, and if you don't know what big O is or any of that, or then, I'll make a video about it, or you can look it up online. But basically, one of the things we can do when we have this recursion tree is we can look at the number of nodes. So this would be a node here, this would be a node, this would be another node, node. So what we're going to end up with here is approximately, in this case, we're going to end up with 2 to the n nodes. Okay, so that's how many times that this function is being run. Now, for us, it's, it's not, exactly going to be 2 to the n, because, our recursion formula isn't 2 to the n, right? So it's not exact, but it's close. So because of that, we're going to end up with this time limit exceeded. Now, there is a better way to do this. And so there is a better way. And, if we used more values for n in our diagram, then we may be able to see this other pattern. So like one way that we might be able to come up with a better solution is if we used more values of n, or if you've ever seen a recursive problem like this before, you may already know of a better solution that we might be able to try. So in the next video, we're going to talk about the better solution. All right, so that's it for this video. I hope it helped, And like I said, stay tuned for the next video and we'll come up with an even better solution to solve the problem. And, be sure to subscribe, comment, like, and ask questions in the comments below, in the Discord chat. And there'll be a link in the description for the Discord chat and for the GitHub repo, which will have all the notes and code for all these examples.